Felix is Imperial student newspaper. You probably know that. But what you might not know is that it's been publishing for over 3/4 of a century. So we have a massive archive of print newspapers that's over 1,800 pages large. And so this is just 1 year of Felix, actually. And there's 75 more of these in the archive. But they're gathering dust, and actually accessing any of those articles is really difficult for all but the most dedicated researcher. So the idea is, how can we use computing to make this archive more accessible to students, to people who are interested in Imperial's past, to find out about your society, about the events that have been on at the college, and more. For example, back in 1966, one author wrote about how they imagined a future where there would be no lecturers at all at Imperial, and how lecturers would be replaced by personal teaching machines. And that was 50 years ago. And it seems we finally come there, but articles like that were very forgotten for decades. So you might, well, it's quite a large thing. Thanks to a massive digitization effort in 2009, they scanned in 35,000 pages of the archive, and we now have them in digital form, but they're still just massive PDFs that are really hard to make sense of, and even Control F doesn't always work, because the OCR accuracy that they could get was actually only 80%. Funding was tight, and 80%, it might sound tolerable for a human, and you can probably still just about make out what the text says. But for any kind of automated analysis, actually reading that text is really hard, because especially transformer-based models like large language models, they really mess up on errors in text like that. But OCR has thankfully moved on in 15 years since. But it's not just about reading the words, it's about reading them in the right order. And it turned out that actually newspapers might be one of the hardest kind of medium to digitize. Because unlike a book where text flows from top to bottom, one line at a time, linearly, newspapers have all kinds of funky designs. So starting with something like this, where first of all it's multi-column layout. But you might think, okay, maybe someone can figure out how to split it up into columns. The issue is that it doesn't mean that you're reading the page in these columns from top to bottom at all, because there's also these dividing lines which the computer needs to pay attention to, and the text is actually read across the columns like that first, before proceeding further down. And for an optical character recognition, which operates at the granularity of a single character, it's actually really hard to tell the difference between a particularly large space between two words or the margin between two columns. But even suppose you could deal with that. Newspapers have even more complicated layouts, starting with something like this, which is just one puzzles page, but where the page is, the text is all over the page. It's not even printed up right. Some of it isn't even English characters, and furthermore, the background is made of question marks, and the optical character recognition goes absolutely haywire trying to transcribe all of those question marks. But it seems like there may be a solution in sight. Large language models have proved really promising at understanding both the language of the page and the layout, now that they can take these entire pages all in one go and read them in the same way that you might. So if I zoom in on this article, I see occupations, and this is what the model transcribed, which is about as accurate as it gets. So it managed to make its way past all the slanted text and the question marks and get it spot on. But the thing is that we've got articles like this, and transcribing them is actually surprisingly accurate, and also now very cheap, as opposed to the thousands of pounds that the archive was quoted back in 2009 for digitizing it. This only cost £120 using Gemini. And evaluating the accuracy, we get an accuracy rate of 0.4%, which actually, at this point, is the nuance between using a single quotation mark and a double quotation mark, or missing a comma. So if you omit the punctuation, the accuracy is 99% word level precision. But the thing is, you have 100,000 of these articles now, a database of more than 100,000 of them. Still, finding anything in that is still really difficult. Actually, 32 million words, some back of the napkin calculations suggest that even if you dedicated it, you made it your job to read Felix, it would still take you several years to read all of it. So that's where Felixplore comes in, which is the web app that I built for exploring the archive online. It's a website, and we're using search, both keyword search and vector embedding search, to get you the most relevant results. So if we start with something like rent hikes, and it finds you articles about rent increases, starting with a recent one. But it's not just about finding the articles that you know, because actually, if you don't know what's in the archive, finding anything in it is really difficult. How do you know what to search for if you don't know what's there in the first place? That's why I built a recommendation engine, which I call more like this. It uses a special model called News Deja Vu, which finds not just similar articles, because you don't want to read more of the same story. You want to find something a bit different, perhaps at a different time period to contextualize the story that you're reading. So here, this article about rent hikes is complemented by articles from decades ago telling of a similar story, how rent prices went up and students complained. But furthermore, there's a... But still, when you're reading at the granularity of an article, it might be harder still to notice the way that the way the archive has changed over time. And for that, I built a trend analysis tool that lets you see how much the newspaper has reported on certain topics. For example, if we search for rowing, we observe how the proportion of articles in that year across time has decreased as rowing has become less popular and spectator sports have generally decreased. On the other hand, something like puzzles has gone up in popularity. It's always been a mainstay of the newspaper for many years, but especially in recent years, as students get their news from elsewhere, they still turn to a physical newspaper to solve some puzzles. So they take up a larger proportion of the issues published. And finally, for a more interesting trend graph, let's search for music, which shows this interesting spike in the late 90s. So before that, students wrote few music reviews, but then as music became more accessible and students wanted to share the music that they've been listening to and the music they'd recommend, the number of articles shot up. There we go, 16% of the articles in 2000 were music reviews, actually. But then when the iPod came out and suddenly you could find all your music recommended to you by iTunes, the number of articles dipped again. So that's Felixplore. And so what I managed to do was turn 35,000 pages of material into an explorable, accessible archive that you can search. Feedback has been really positive, and you can go and explore it yourself at explorefelixonline.co.uk.
Thank you, Elton. I wasn't quite expecting you to be at the end, so I'm staring at the start of the report. So I'll hand that over temporarily to Ivan, who hopefully has already read the report.
Yes.
And have some short questions for her.
No, I was just reading them. Of course, I read them. Thank you so much. It was really fun, actually, to see it and to read the report, I have to say. I think you haven't unpacked a lot of the work that you've done in the presentation. There's a lot of interesting points here about how you put together like tools and pipelines and all the experimentations that you did to actually get meaningful text out of the newspapers and to correct the OCR scans, the original OCR scans. So I guess for the benefit of everyone else, if you want to expand a little bit more on those points, that'd be great.
Sure. What shall we start with? Because I've left more time for questions because there is a lot of material to cover, and I'd like to cover what you are interested in hearing about. So perhaps like rejoining articles or copyright issues. What do you think?
I was saying, the more you can say about technology, software engineering, the better, because that is what you're being assessed against.
Sure.
So
I think, yeah, you mentioned, for example, there's quite a bit on Tuxar and what you did to
did you take the original scans? So the original scans in 2001 were in PDF, is that right?
Well, the JPEG images, yes,
Okay.
35,000.
Did you go back as far as rescan?
Yes, so because that 80% accuracy that they managed to do back then wasn't suitable, and I thought that I could get the text done in a matter of weeks, and I didn't think it would be such a substantial part of my project. But yeah, so I redid the whole text extraction process. Large language models proved to be really promising, and that took definitely a lot of iteration with different prompts, different output formats. How do you tell the model what order to read it in to make sure you get good output? And it did manage to produce good output.
So what did you do? Sorry, yeah. You mentioned large language models.
Yes.
What did you do? What did you do there?
So
go from the JPEG to the new 0.4% error-free.
yeah. So you take the scans and you feed them into the model, each one by one, with a prompt, and you tell it, well, you're a typist, you're transcribing it. I tried different output formats, JSON, XML, and I settled on HTML because actually, well, it's great for representing web pages. The models have seen lots of it, and so they're actually do a decent job of transforming the page into an HTML document, which I can then pass. I tried different models. I tried the three main models: Claude, GPT, and Gemini. And the reason that I chose Gemini is, well, primarily the deciding factor was that actually these scans are really large. Some of them are 7,000 pixels wide, and especially older editions were actually printed in a really small font size as well. So 6-point text, so that's like half the normal size that you're used to now. And so you really do need that resolution to be able to read it. And Gemini can handle images up to 3,000 pixels wide, so it can take that entire page in one go. Whereas GPT can only handle about 1,152 pixels, so it can't, it pretty much doesn't see anything at all, so it's no surprise that it hallucinates. Whereas Gemini, which is that's roughly an approximation of what Gemini sees in the middle, it can actually read the text really accurately.
So is there not just how did you know you were, how did you get that 1.4%? How did you know you want that?
Yes.
I didn't know that, well, yes, how did you get that?
So, of course, transcribing issues manually takes a really long time. So I sampled one text-dense page from every decade and manually typed it up. Then, ran it through, compared it with the output of the large language models. Sometimes they actually transcribed it more accurately than I did, but with their help, I corrected the errors that I had made, my typos. And then, so I established a ground truth of about 20 articles and compared them against the models again.
So yeah, you did resort to basically passing the scans to large language models to get the digitization in HTML format that was asked, right? A crucial element here was to get the prompt right. There are still things that you say that you may need to improve, and mainly the one that I mentioned down was the category bit, because you found out that you were a bit lax with that one. But I was interested in knowing, and I think this is like an element that we will end up focusing a lot more over the course of the next few years. How many prompt iterations did you actually go through, and how did you select the bits of articles that induced you to change a part of the prompt to actually refine and better the prompt?
Yeah, well, I suppose for context, I should bring up the prompt when I describe it. So one of the balancing acts with writing prompts is that obviously you're repeating that prompt for every single page you process. So I'm trying to keep it both really concise and really dense instructionally. So I managed to get it down to 174 tokens, which summed across the whole archive is less than $1 for prompt costs. So but it really did need to be quite specific. And how did I modify it? Well, that's why I created my pipeline, which allowed me to quickly take a page, scan it with a slightly modified prompt, see how it went, compare them side by side, and go, well, is this what I expected? Is this getting better? There are now, as well, automated techniques for prompt optimization, like DSPY, but since I didn't dedicate myself to that, the prompt generation itself, and so I just kept iterating on it until it seemed to produce reasonable output. But there are, especially, the difficult part here is that I didn't have a ground truth data set, a particularly large one at least, so it's hard to say optimize numerically for what makes the best prompt. So it was a bit more subjective here, but suppose I could spend the time, get help to transcribe more issues, then you could numerically optimize it with something like DSPY to get a really good prompt. But this seemed to produce the results I needed, so I settled on that, yes.
I was going to ask you about your data dashboard is really the main thing you presented to us. Is that every issue of Felix from 1950 onwards, complete with the sample issues?
It's pretty much all of them, as in all of the ones that was scanned. So this is a graph of the number of pages in the archive per year. And actually, about 90% of it we have in its digital form. So some of them were, like the 1978, 1979 issues were missing at the time of digitization. We don't have those. And we also are missing some at the start of the early 2000s. But largely, it's all there. So that's about 90% of all the pages that were published. I did manage to process. The pages that are missing would actually make for a great test data set because those have never been online and the large language models could not be trained on them. Yeah, so there was of the pages that we have digitally, 98% of them Gemini processed. The remaining 2% were it failed to process because of copyright consent.
Okay, and can you tell us a bit more about how your search mechanism works? So what techniques you use to develop that, what the technology is behind it, etc.?
Yeah, so the search started off with, all the articles are loaded into a PostgreSQL database, and that offers built-in full-text search. So that's for keyword searches as we're used to. But of course, especially with an archive, it's hard to, you don't know what the keyword is you might be searching for. So for that, I also added semantic search using embeddings. So I'm using Gemini embedding, which is still the model at the top of the massive text embedding benchmark. And so I'm getting the most relevant articles both by keyword search and by vector embedding search. And then I'm combining the two using reciprocal ranked fusion. Sorry.
Okay, can we test it now?
Yeah, absolutely.
Yeah. So, I mean, for instance, when my colleague in the office, David White, has done a lot of work with Felix.
Right.
So, I'm interested in what you find if you search for him.
Got some contributions for the public.
Oh, please recognize that some of this stuff is online.
Well, I know it's interesting. That does not seem to be about Duncan.
No, I mean, even though it sounds like you might have done, I'm sure that's not the thing, but
yeah. Well, so
but he used to supply those puzzles, if I remember. So yeah. I see you got one there, or two there.
Search for exact matches.
Yeah. I think I can even put it in quotation marks actually to say Duncan. Yeah. So it is all. Does seem to all be puzzles. Yeah. Well, because there's no semantic meaning to the name, really.
Yeah.
We have space for more questions.
You've got 10 minutes,
So, more on the human-centered design aspect of this, because I thought it was crucial for Felixplore in particular. How do you choose good metrics to evaluate the archive navigation effectiveness?
So by that you mean the recommendation on the side of the page?
Yeah, recommendations, what to filter for, even the strictness or laxity of the work to vector embeddings and similarity.
Yeah. So perhaps I'll start with the last one there for the trends page. That is using purely embeddings because it's designed for searching for topics rather than for exact people. For the trends page, I've empirically determined that a threshold of 0.65 distance in this multi-dimensional space was sufficiently filtered out enough of the stuff, but without including too much irrelevance. So, as in one example where it perhaps doesn't work so well is like if you search Tiananmen Square for trends. There are these spikes in 1989, but there's also this odd article in 1958, simply because it mentions a Chinese evening. So there are some flaws to it, but for the most part, that threshold, which I can tune, of course, and I could just simply lower the threshold, that wouldn't show up. That is one tuning parameter. For the recommendation search, that was using Use Deja Vu, and I've compared it to using just normal, ordinary embeddings like Gemini embedding. And for that, I created, what I did is I modeled the whole archive as a massive graph. And where's the graph of graphs? There's the graph of graphs. And so the idea was, well, we're going to recommend not too many articles to overwhelm the user with recommendations, but enough to capture most of it. And so actually what we've got on the y-axis here is the strongly connected component that represents the bulk of the articles in the archive, that they're all actually navigable to one another. And so I settled on 8 recommended articles, which with Use Deja Vu gets you about 80,000 articles, or 80% of the archive is easily navigable, well, or at least is possible to navigate between one another. The nuance in that, of course, is that sometimes you might need to take a really specific route through these recommendations to laterally traverse the archive. But that's to be
topics, right? Because you would need sometimes to jump from a topic or area to another.
Exactly.
The intersection article are very few.
Yeah.
Right.
So, well, a newspaper writes in sections, so you can expect articles on politics, you can expect articles on sport. You might not necessarily expect many articles that talk about both politics and sport, and those few that do will be the bridge between these two topics. So there's about 50 topics like that.
So, but I think what role, if you go,
No, you can ask.
no, you go ahead. I think you
Yeah, I feel there's a lot of content that you could have included in your presentation because the report is pretty dense. So maybe if you can tell us all the features of the Felixplore web application. Like I see exact matches, and other than that, what are the other features?
Well, so for the search, if we search something like intelligence, we can get both results which are exact match, which is using full text search functionality. That in some ways we might find that a more powerful option, because that also lets you exclude specific words. So you can search for like the word election but without the word poll. And same concept is using purely lecture embeddings. Yes.
All results.
Yeah.
How are you computing? What is the weightage of
They're equally
exact
weighted.
match?
They're equally weighted. So it gets the results both using full text search and using the embeddings, ranks both of them, and it weights them equally. So articles that rank highly in both end up at the top.
Yeah. I think there's one part that I was keen to explore and at least like to share with everyone else in terms of maybe your thinking, anything that you may have thought beyond what you put in the report. So there was one problem that you couldn't overcome.
Yes.
And that I think you I guess to some extent smartly kind of delegated to the future, the near future. And that is linking together chunks of articles that were, by decision of the editors, like split and separated in the issue.
Yeah.
What do you try? What would you try more that you haven't tried already to kind of overcome it? And then, again, if you can also like include the option that you actually set up for.
Yeah. So yeah, the issue with newspapers is that the articles don't always start on one page and finish on that same page. You can have articles that start on the front page, and then you have this, which is known as a jump line, where it says continues on another page. So, and there's lots of these. You have these teasers, which says read more on page 9. And so you might say, well, we can take articles which start on the front page, see if they say read more, and try and find something else. But the issue is that, of course, it's not so simple, and some articles might start on the back page and continue deeper in the issue. And some articles, well, naturally they flow from one page to another. So effectively, an article can start anywhere in the issue and continue anywhere else, and it might span 2, 3 pages. So joining them up is quite difficult. So what I tried, well, first, I tried writing regular expressions that would match things like read more on page 3 or continue from page 7. And I found about 1,000 articles that had those kind of explicit markers, which is only about 1%. And that locates which ones, but how do you tell which one to join to? So first I tried embeddings. I said, okay, well, let's take the last few sentences before a jump line, embed those, and then embed the first few sentences of every article elsewhere and see how that compares. And that definitely helped to narrow down the number of possible matches, but actually it wasn't strong enough a signal to concretely say these two articles should be joined together. So after that I went, well, perhaps large language models, because they are really good at predicting all they do is predict how the text might continue, right? So I said, well, if we join the two and say compare how surprised the model is by the continuation, so the perplexity, as they call it, of the text that it continues. But what I found is that actually the model is surprised by the first few words of a continuation, but then afterwards the perplexity is largely measuring just how coherent the text is, the rest of it. So that also wasn't a strong marker. So what I tried is I said, well, let's see the perplexity of the first few words of a continuation, and also use embedding to narrow down, because calculating complexity is really slow, narrow down the number of possible matches using embeddings. But I still wasn't satisfied with the results. And obviously the cost of joining two articles incorrectly is actually quite high, because you don't want it to have crossed lines where you start on a cooking article, continue on a, I don't know, nuclear power article. So I decided to just leave them separated. How to solve this in future? Well, there's less research on this because it's not such a wide issue, but one paper from 2021, they trained a language model, BERT, to classify just yes or no, given two snippets of text, whether one is the continuation of the other. And it achieved a pretty decent accuracy of 90-something% when given two pairs to compare. But when given a choice and saying, well, these 10, it could be continuations, pick the best one, there it failed miserably. So perhaps training a model like that, or perhaps even just large language models are now good enough to do that. The issue is, of course, that would be quite expensive, especially because of the number of pairs that we'd have to compare. So I wouldn't want to spend just as much on rejoining 1% of the archive as I did on extracting the whole thing.